So we are going to be working through 13A and 13B of the Unit 1 and 2 Methods Cambridge textbook. So we are just focusing on our understanding of index laws. So all of this is revision. So our first law that we're looking at is our multiplying powers. So that means if our base is the same, we are just adding our powers together. So that means for this, the first thing I look at is I look at my coefficients and I'm timesing them together. So 5 times 2. I'm then looking at how many exponents are timesing. So I've got 4 and I've got another 3. So 4 plus 3. And then I've got 2y and another 5. So I'm just adding them. So then I just go 5 times 2 is 10. I've got 7 x's and 7 y's. Again, when we got 6m to the power of 5, n to the power of 2 times 3m squared, n to the power of 4. The first thing I'm going to do is look at my coefficients, which is 6 and 3. So they are times together. I then look at my powers of my m. So I've got 5 and 2. So I add them together. And I've got my n. So I've got 2 and 4. So I'm adding them together. That gives me 3 times 6 is 18. I've got 7 lots of m's timesing, and I've got 6 lots of n's timesing. Law 2 is dividing powers. That means we are cancelling. So when we're cancelling, we're just taking away. So if the first thing I'm going to do here is simplify my numerator before I do anything else. So that means I've got 12 times 3. I've got 4 lots of x's and another 2, which is 6, and I've got 3 lots of y's plus another 1. So that then, if I would like to simplify this, I'm going to simplify it with looking at my coefficients. So I've got 3 times 12, which is 36, and then I divide it by 6 and I get 6. I'm now going to simplify my powers on the bottom. So on the top, so I've got x to the power of 6 and y to the power of 4. I then am going to apply the rule to the divide power. So that means I'm cancelling. So I've got 6 lots of x's on the top. I'm cancelling 1. So I'm taking 1. I've got 4 y's on top. I'm cancelling 2 out. So I take away 2. And that gives me 6x to the power of 5, y to the power of 2. Index law 3 is raising the powers. So that means if I've got 3 on the outside here, another way I can write this, I'm just going to write it here, is I'm really saying I've got a to the power of negative 2 times a to the power of negative 2 times a to the power of negative 2. 3 lots of it. 3 groups. When we talk about groupings, we're talking about multiplying. So I'm just going 3 times negative 2, and then for the negative 1 power, I'm timesing it with the 4. I will then simplify this. So negative 2 times 3 is negative 6, and 4 times negative 1 is negative 4. Now, because we're timesing, our base is the same, which means I'm just adding them together. So that means I've got negative 6 plus negative 4, and that gives me a to the power of negative 10. Our next one is product. So likewise, what we showed before is we're just doing multiple groups of these timesing. So that means this n is applying with everything inside my bracket. So that means here, this power of 2 is going to be applied to the 4, and that 4 is like me having a power of 1. So it'll be 4 squared. Then I've got x to the power of 3. And again, I'm going to apply that with the 2. Then I've got y squared, and it'll be times 2. Okay, and it'll be identical for the other term. So the first thing, I'm just going to apply that understanding. So that means that power of 2 is applied to everything, including my 4. That negative power of -1 is applied, including my coefficient. So now from this, the next step is just simplifying. 4 squared is 16. Um, we've got 3 times 2x, which is 6, and we've got 4 lots of y's. Same thing applies here. We know 2 to the power of -1 is a half. X to the power of 2 times -1 is just -2, and y to the power of 5 times -1 is -5. This is where we can simplify it further. So I'll just look at my coefficients. Half of 16 is 8. And then with my powers, because we're timesing, I just take them away. I group them when the base is the same. So I've got x to the power of 6 plus -2 and y to the power of 4 plus -5. That simplifies down to 8x to the power of 4, y to the power of -1. Okay, now we're going to look at the is quotient, index law 5, looking at the quotient. So it's the same thing, but in terms of on this outside the power, it applies to the numerator as well as the denominator. So it's very similar to the product. It's just applying it in terms of a fraction. So with this question here, the first thing I want us to think about is I would like to apply the 2 to everything inside. So that means that power of 2 is applying to the 3, so it'll be 3 squared, is applying to the a squared, so it'll be 2 times 2 as my power, and my power for b will be -1 times 2. And the same thing applies to my denominator. So now I've done that, I'm just simplifying. We know 3 squared is equal to 9, and then a to the power of 4, b to the power of -2. Likewise, I'm going to do the same on the bottom and make it x to the power of 4, y to the power of 2. Now from this, I just need to simplify it if I can. Do I have anything that's similar on the top and the bottom? No. So I can't simplify it, which means I'll leave it in this form. The other couple that we need to be thinking about is our zero powers. So that means if we have a power of 0, instantly it's just going to give us 1. Likewise, if we have a negative indices, and I haven't changed it because I hadn't gone through this yet, is that if we have a to the power of -4, that's the same as 1 over a to the power of 4. So let's have a look at some of these questions. So prime is decomposition. So the first thing here is we need to try and work out getting it to be the same base, because at the moment these do not have the same bases. So I can look at 6 as 2 and 3, because 6 is not a prime number, and 12 is the same as 3 times 2 times 2. So going back to breaking it down, looking at the prime numbers. Now, if I wanted to use my understanding of product rules, or I could say the power rule, this 4 applies to the 2 and applies to the 3. Likewise, this -3, it applies to the 3, it applies to the 2, and this 2. So I rewrite them separately. Now, I just need to think about what I have here. So at the moment, I'm just going to underline, I've got this is a 3, this is a 3, and this is a 3. So I'm going to group those powers together, and it's timing, so I'm adding them. Likewise, I've got a base of 2 with these 3, so I'm adding those powers. Now I just simplify it. So -3 plus -3 is -6, -6 plus 4 is -2, and 4 plus -3 is 1, 1 take away 3 is -2, and I rewrite it. Okay, let's have a go. So if I've got 2 to the power of n plus 3 times 4 to the power of n take away 1. Then I've got 8 to the power of n. So straight away, I'm wanting to get them down to be the same, which will be a 2, the same base. So to get 4 down, 4 is the same as 2 squared, and 8 is the same as 2 times 2 times 2, 2 cubed. Now I've done that, I just need to look at the next step, which is making sure 2 is just going to be my base. So that means I'm wanting to get this 2 on the outside. So I'm just going to rewrite it. Likewise, this 3, I'm going to put it onto the outside. So now I've got it as 2 to the power of n plus 3 times 2 to the power of n minus 1 over 2 to the power of 3n. So now my base is the same here, which means for my numerator, I can just add my powers together. This is where we need to simplify our powers. So the first thing I'm going to do here is I'm going to go times it. So 2 times n is 2n, and 2 times negative 1 is negative 2. Now I can add the like terms. So I've got 3n, and then 3 take away 2 is 1. So the next step is I need to now look at, we are dividing using the quotient rule. So that means we are taking away, we're cancelling. So I'm going 3n, take away 3n is cancel, and that leaves me with 2 to the power of 1, which is 2. Let's have a go at this question. So again, we've got 27 times 3 to the power of 4 times 6 squared over 3 to the power of 6 times 9 times 2 to the power of 3. So the first thing we need to do is rewrite them in a more basic form, looking at trying to get them to be the same base. So we're going to focus on prime, um, the primes. So that means we've got 27. I can say 3 times 3 times 3. 6 can turn into 2 and 3. 9 can be 3 squared. So now I've done this, I'm going to simplify before I worry about this bracket. So I can simplify this part here because they both have a base of 3, and I can simplify this because they both have a base of 3. So I can add my powers together, and that will give me 3 to the power of 7 and 3 to the power of 8. I then apply this to both of my numbers. So I've got 2 squared and I've got 3 squared. The next step is, again, I'm going to simplify it as much as possible. So I've got 2 base 3s on top. So I will then add my powers together. So that will give me 3 to the power of 9. This is where we can simplify it as the next step. So we are now looking at our what is common. So here we can see we've got 3 to the power of 9 and 3 to the power of 8. So the step that we can do is our subtraction. So I'm going to say I've got 9 and I'm taking away 8, and I'm timesing, and I've got 2 and I'm taking away 3. So that's just going to give me, change to black, that's going to give me 3 times 2 to the power of negative 1. Now, if we know our understanding of powers of a negative, we can take it to the bottom and it becomes positive. The next part we need to know is our rational indices rules. So we know if we have a square root, it's going to be a power of a half. If we've got a cube root, it's going to be a power of 1/3. So this is where we need to understand this relationship of if we've got a to the power of m over n is going to be equal to a to the power of 1 over n in brackets to the power of m. So let's have a look at some of these questions. If I've got 8 to the power of 343 over 1/3, we need to understand what rule we are using. We're using this rule right here, which I said before, if we have a power of 1/3, it's doing a cube root. So I've got the cube root of 8 over the cube root of 343. We know the cube root of 8 is 2, but for this one here, you need a calculator to do it, and it will give you 7. So we got 2 over 7. Likewise, if I've got 1 over 64 to the power of negative 2 over 3, the first thing I'm going to do is I'm going to apply this negative. If I apply that negative, it means these two numbers are going to be switching because it's really saying that I've got 1 over 64. Both of these have got a power of -1, so they will switch around. And then underneath that, I've got all of that to be the power of 2/3. So that just switches. Then I use our understanding of our square root rule. So if it was just 1/3, it would be a 3 on the outside with this n. But because we got that 2 associates with being in here. So it will be 60, the cube root of 64 squared. I can simplify that down to 16.